Hey guys, so I'm sick, so I can't be there today. But I'm gonna do the notes on my Chromebook. Not done this before, so bear with me if it's a little sloppy. But so anything I write over here on the right side, I want you to write down on a piece of paper. So we're gonna start by just labeling that this is 8.2 notes. Okay. And on the left side are just kind of the reference. So yeah. So on the left here, we're doing trig ratios. I think a lot of us kind of already know. It sounded like you guys said the other day that you know these. So a lot of times you can remember a SOHCAHTOA. When you hurt your toe, use SOHCAHTOA. So if you have a right triangle, and we call this A, and this would be the opposite side. This is the adjacent side, and this is the hypotenuse. Then from that side A, we can say that sine of that angle A equals opposite over hypotenuse. That cosine of A equals adjacent over hypotenuse. And I'm not sure if you're realizing it, but adjacent over hypotenuse. And then finally that tangent of that angle equals opposite. That's O over A, which is adjacent. Okay. You have to have those memorized. Sounds like from what we were talking about the other day that you might actually have those memorized. So let's go ahead and look at some of the stuff they want us to do with this. Okay, so we have this triangle, and they just want us to write the ratios for it. So we're going to write the right triangle, and its H is up here, F is here. This is 9, 15, 12. So the opposite side depends on which angle we're talking about. So they want us to do angle H. So that means sine of H. So that opposite is down here because that's opposite of that angle. So that equals 12 over hypotenuse, which is 15. For H, cosine of H. So CAH. So CAH is adjacent. So the side next to it. So that'd be 9 over hypotenuse, which is 15. And then finally TOA, which tangent of H equals opposite of H, which is 12, over adjacent, which is 9. And then they give us the next problem, which is going to be the same triangle, but now they want us to talk about it in relation to F. So now that makes this one opposite and this one adjacent. This one stays hypotenuse no matter what. So if I have to do that, I'm going to write down all those. I'm going to get rid of these real quick just so you're not going to erase them, but I'm going to erase them real quick. Just give myself some room. Oh, didn't need to erase that. So, yeah, so we got to be careful that we realize that that it's a different, that sine of F is going to be opposite. This one's now opposite. So 9 over adjacent, which is 15. Wow, that 9 is ridiculous. Over 15. And then we have cosine of F equals adjacent, which is 12 over hypotenuse. And finally, tangent of F equals opposite over adjacent. Okay. So that's pretty standard. Nothing too crazy yet. So then they want us to be able to talk about our special triangles that we've dealt with. So our 30, 45, 60. So we have, we should know some rules about our 30, 60, 90 triangle. Okay. And we learned that, so we learned that, oh, they give us the 45, 45 first. Oh, that was nice of them. So we learned this picture the other day. So they're going to just say very generically that if this is 1, then this would be twice as much, and this would be 1 times square root of 3. They just call it square root of 3. So with that in mind, they want us to find what the sine of 30 degrees is, cosine of 30 degrees, the tangent of 30 degrees. Okay, so we need to know that, memorize this triangle so that we can do this. So sine is opposite over hypotenuse, so that means that equals 1/2. Cosine is opposite over, no, excuse me, adjacent over hypotenuse, and tangent is TOA, opposite over adjacent. So that's 1 over square root of 3. They're not going to like that we have it 1 over square root of 3. What they're going to do is they're going to say, well, let's just times this by square root of 3, times this by square root of 3, and that gives us 3 over square root of 3. We'll talk about that later, okay? And then they want us to know the cosine ones. So cosine of or I'm sorry, not the cosine, but the 60 degree. So 60 degrees for all of those ones we just talked about. So sine of 60, cosine of 60, and tangent of 60. So now we're talking about this angle. So its opposite is square root of 3 over hypotenuse is 2. Its cosine is adjacent over hypotenuse, and tangent is opposite, which is square root of 3 over adjacent, which is 1. Or they're just going to call that square root of 3. So basically what we have over here, we're just kind of creating based on that. Now what's going to happen is you're going to be expected to know all these. So what I would expect to see on a test or a quiz, where I don't let you use a calculator, you're going to have to draw this picture and kind of recreate that. And then we got to be able to do the same with a 45, 45, 90. So that one, they're going to say, let's make the most generic one would be these are 1s, and then this would be 1 square root of 2, or we can just call it square root of 2. So the sine of 45, and we don't have to do these ones twice because they're both the same angle. And it actually doesn't matter which one we pick. If I pick that one, opposite over hypotenuse. And again, they're going to do this weird little trick where we don't like the square root to be on the bottom. We'll talk about that later. Cosine 45 equals opposite. I'm sorry, so sometimes I like to write that out because my brain just forgets for half a second. So that's 1 over square root of 2, which is the same as square root of 2 over 2. And then finally the tangent of 45 is opposite over adjacent, so that just equals 1. So we're expected to kind of be able to create those just from drawing those pictures. Let's see here. So here's a problem they're going to give us, and this would not be a question we would have a calculator for. If we had a calculator, we would simply just plug in the numbers and we would move on. Okay. or actually we can use the rules that we already know, which is that this is, I'm sorry, that this is 6. Then this other side here has to be 6 square root of 2. Okay, so we'll just draw that real quick. We've talked about this. So 45, 45. If this is 6, then our rule is that this is 6 square root of 2. And then same with the second one. Now they're bringing in the trig identities here to say that we know that trig, that this equals 1 over half. Okay, so that's another way we could solve that problem. We'll skip this one, but we could use that same rules that we learned the other day about 30, 60, 90. You have to have those memorized. Let's see here. I'm going to go on to this next page. So on this one here, we're actually going to use a calculator. So you can notice that they basically are not going to let us have a calculator if it's a 30, 60, 90 or a 45, 45, 90. This is 12 degrees, so we're going to be able to use a calculator on this one. So basically all we have to do is set up the equation that works. This one's going to be, so let's go ahead and just draw this picture on our notes. That's 12 degrees, that's x, and that's 12.5. Hopefully you're writing this a little bit nicer than I am. It's hard to write on the screen. So this is the opposite side. This is the adjacent side. So which trig function makes sense is tan. So I'm going to go tangent of 12 degrees equals x over 12.5. Okay, so now we're going to use a calculator, and I'm going to times this by 12.5, times that by 12.5. So then I know that x equals whatever I get when I do tan of 12 times 12.5. So I have to go to, I'm going to use the Desmos calculator. So I just typed in desmos.com and use the scientific calculator. I don't think the 4 functions will let you do the tan functions. So I click here on this functions. I go to tan, and it was tangent of 12. Go tangent of 12 and hit enter. And then I'm going to just times that. So I guess I could have done tangent of 12. I guess I got to do that in one thing times 12.5. And basically, we're just getting that answer from the calculator. Let's see where it says to round. Okay, it doesn't say to round, but we're talking, well, here they do 12.5. So we'll go ahead and give it one decimal place. So it's this height would be 12.7 when we round that. Okay, so x equals 12.7 miles. Okay, let's see what this next one is. So this is essentially the same type of question without a picture. We don't need to do that. Okay, so what is the measure of angle one of A and B? Okay, so when we have the calculator and we want to figure out the tangent of an angle, we just type in tan of that angle and we get it. So this is where it's going to get a little bit different than we've probably seen before. We're still using the same methods. We got a 1 and a 4. And I have to just pick, what is the measure of angle A? So I'm going to go here and say measure of that, and I have these two sides. So in relation to A, this is the hypotenuse, and it's going to be the hypotenuse for either one, and this is the adjacent. Okay, so which trig function has a hypotenuse and adjacent? That's cosine. So cosine of A equals 1 over 4, because cosine is adjacent over hypotenuse. But the question wasn't what is the sides, and we're used to that. So we have to go backwards, okay? And in order to go backwards, there's a special key on the calculator. So if I go to cosine, if I were in class right now, I would say, what do you guess is the backwards button? And I would hope that somebody would say this right here. So that's what that means, is you're going backwards. So this means I'm going to stick this in there and it's going to spit out that. Okay, it's called inverse. So I'm going to type in 1 divided by 4, and it's going to tell me what the angle is. Okay, and there it tells me that that angle has to be 75.5 degrees. So angle A equals 75.5 degrees. And then we're going to do the same thing now with B. But B had this side here is opposite to B. So that's O, and that's still hypotenuse. So opposite and hypotenuse, that's sine. So we're going to go sine of B equals opposite is 1 over hypotenuse is 4. So then I go back to my calculator, and because it's sine and I want to go backwards, I'm going to hit the sine backwards button, and I'm going to get 1 divided by 4. And I'm going to get 14.5 when I round that. And we should be able to add our three angles now, 90 degrees, 75.5, and 14.5. Let's try that. So 90 plus 14.5 and 75.5 plus 75.5. That should equal 180, and it does. Okay, so that gives us confidence that we did that problem correctly. So here are more of the same question where it's going to ask us to find the measure of P. I'm going to say that's opposite over adjacent, and then use that backwards function to find that out. So here's the rules again. Okay. Got to know those. So here they're asking for us just to write down the ratios. So they give us the triangle and they ask, what's the trig ratio? What's the tan of B? So sometimes they just like to ask for us to come up with the fraction. I'm going to write down the triangle, the tan of B. So there's my B. So that means tan of B equals, and they're not asking us to find B, they're asking us just to write the fraction. Tangent is TOA, so that's opposite over adjacent. That's just 3 over 5. Okay, so that's what they're getting at when they ask for that ratio. They want us to find that fraction and not do anything else with it. So then they ask us to do the same thing, but now cosine of that. So cosine of B, cosine is adjacent over hypotenuse. So adjacent is 5 over square root of 34. And if you haven't kind of figured this out yet, this ends up being 34 on the bottom, 5 square root of 34 on top. And we'll talk more about that. I'm sure you're confused by that. We haven't really talked about that. And here's, they're asking for sine now. So sine is opposite over hypotenuse. Sine of B, 3 over square root of 34, or 3 radical 34 over 34. So here they're asking us to find the measure of angle B. Okay. So we would just use this right here, and I could tell that B, the measure of angle B, that's a backwards problem. So I already have the answer in a sense. So I just go tan inverse of 3/5 of 3 divided by 5. Oh, I don't know why it does that. And it tells me that that angle is 31 if I round that to the nearest tenth. So then that's 31. And you should be able to find the other ones by just typing this in cosine inverse, sine inverse for those. You can see that they're asking for those now, and so forth. And I think that should pretty much cover all that we need to talk about. Really, the only thing that we haven't seen maybe in the past was how to get this angle out of here with that inverse. So you do have, I already put the online work online, and you do have a group quiz. That group quiz you can just write on another sheet of paper, and you will not have to put it on. I won't give you a copy of that paper. You just need that paper that you write it on, and make sure you clearly identify which problem is which. Sorry that I couldn't be there. I will hopefully see you on Tuesday. Bye, guys.